Good afternoon, my name's Geoff Huston. I'm from APNIC. This is an update on resource certification and in particular looking at the use cases around using these kinds of resource certificates. Most of you come from an operations background and I'm sure you've seen this kind of email. This is one that came from my deep and dark archives when I worked in the telco. In Australia, when anyone ever calls you mate, watch out, because they want something from you and they want it bad. So when you see something like Geoff mate, then you're in deep trouble. And certainly this kind of mail message is not unfamiliar to most of you, where they complain about the front of house, they say they're getting absolutely nowhere, things need to happen in seconds flat, they tell you at the end of the day, and all you want to do is go home. And of course, the immediate reaction of servicing their demand, because after all you're trying to do the right thing, is that you get trouble tickets. And this kind of trouble ticket is probably one you've also seen, where as a result of doing the right thing, or so you thought for someone else has just been cut off, because it really wasn't a clean route that you actually just put straight in. That's okay, but you work for a telco. And telcos, of course, have legal departments, so all of a sudden up comes the first thing next morning in your mailbox. Endless phone calls are about to become your life for the next week as you try and resolve what you thought was quite an innocent idea of trying to help someone. So, you know, I'm sure you've all been there, and I've certainly lived that life once or twice as well, and it's unpleasant. You know, in looking back, I kind of think, well, gee whiz, it would have been nice to have figured out who was lying there, because if I could have figured that out, I wouldn't have got into this problem anyway. And one way of doing that is to actually say to someone, well, you know, can you demonstrate that it's your address, really, truly, really? Can you sign something like a route origination request or something else with a signature that is pretty tight that I can then validate? In other words, can you give me an authority as the prefix right of use holder to me, the AS, an authority for me to originate this that I can validate independently? You know, if only that was around. And you kind of generalise this a little bit and sort of look at the situation we have right now and what kind of questions are floating around about routing security. And as far as I can see, there are sort of four very, very basic questions that all of us worry about at some point. Is this someone lying? Is this a stolen prefix? Is this a hijacked prefix? You know, is this prefix really in play? Is it valid? And if I'm looking at someone else's route being sent to me, being advertised to me, who the hell actually advertised that address prefix into the network anyway? And the really tough question, did they have the credentials? Did they have the authority? Did they have the ability to do that cleanly? In other words, are the credentials there to advertise this address prefix? And it's more than just origination. Is someone lying in the AS path route, AS path that's being presented to me? Is that path authentic? Those are very, very tough questions. And what would be really good is if we could answer them, because quite frankly, today you can't. All these kinds of route registries and so on do not give you authoritative answers. They give you best efforts. What would be good is to actually inject a little bit of security into this and be able to use reliable infrastructure to validate these assertions. So that when I see someone saying, please Geoff, route this, when I'm looking at the routing table and saying, is that address that I'm seeing really, truly, really right? Then we should be able to authenticate that that assertion in terms of routing was actually made by the person who has that address. To be able to confirm that that information is correct, complete, unaltered. And to actually convey routing authorities so that the person who has the address can indeed create assertions that can be checked, validated, and aren't forged or altered. So, you know, what would be really good is to have all three of that magic trio, good, fast and cheap, to actually have a reliable and efficient and effective way of underpinning the Internet's address resource distribution structure and our use. And you go, oh yeah, well, routing in the Internet, you know, best effort, we've survived so far, what's the problem? It's a little bit more than routing. I mean, most of you, I take it, were in here looking at V6 this afternoon, yes? and we're going to run out of unallocated address pools feeding the V4 network in some years in the future, and not too many. Will you have V6 turned on by then? Will you have no further need for V4? Or will your V4 network still persist? If they do, where are you going to get addresses from? How are you going to figure out that the person who is offering you some really does have those addresses? And how are you going to figure out that once you've done this kind of transfer or trade or whatever you want to call it, that you now have those numbers and the person who is offering them to you no longer has them? Any kind of system that is going to appear after we run out of unallocated V4 addresses needs to have a number of well-known properties of which right of use and clean title appear to be fundamental. So we certainly need to replace what we have, because the assertions, the rumours and the fuzzy traditions about addresses and their use are prone to incredible abuse continuously. So it'd be good to do better. Certainly in APNIC we've been considering this for some time as a regional internet registry in the Asia Pacific. We're kind of wondering about, well, you know, how can we do a better job here? How can we create trust injection that others can use in a reliable way? The approach that we've been using in a trial that's being conducted last year and across this year is to actually take PKI systems, X.509 version 3 public key certificates, and add to it an extension that describes resources, IP addresses, V4 and V6, and AS numbers into the certificate. We're not trying to reinvent anything here. We're trying to use as much of the existing technologies as we can, leverage on open source tools and deployed systems, and throw back this work as open source solutions ourselves and open standards. The approach we're using is actually based around an open source toolkit already, OpenSSL, and one of the early pieces of work is to add into that support for this resource extension describing IP addresses in certificates, and a huge amount of work on designing a certification framework. So you end up with a certificate which is subtly different from traditional X.509 certificates. It's not that I'm trying to certify that my name's Geoff, or even my role is, you know, this particular role. So it's not a role or an identity certificate. It's something subtly different. It's a right of use certificate. The issuer is certifying that the subject, whoever they may be, whose public key is contained in this certificate, is the current controller. I'm carefully skating around the word owner here. The current controller of a collection of IP addresses and AS resources that are listed in the certificate itself. And the issuer signs across that entire assertion. So how does it work? What does it look like? Here's the way in which we allocate IP addresses and AS numbers in the system right now. There are 5 regional internet registries, and occasionally in some areas, and although I popped them under ARIN, you'd more likely see these things under APNIC and the RIP NCC, there are local registries that handle redistribution functions of these resources. And down the bottom are various forms of service providers and users who actually are the recipients of those allocations. So just note, some of those chains may be indirect. Not everyone is tightly tied to a particular RIR. So what would the certificate do? It would just simply mirror and match the allocation actions, so that if LIR1 has a certificate, it would just simply say what holdings they have from ARIN. So here is one. ARIN would issue a certificate that says the subject is that LIR, LIR2, and the resources happen to be these ones, 192.2.0/16. The key information is the public key of the subject, and it's signed with the private key of ARIN. If you go down one step further, that LIR might themselves issue a certificate saying, I gave a /24 to that ISP. Exactly the same type of certificate, but now the issuer is the LIR, the subject is the ISP. And it's a more specific that's actually been certified in that allocation action. The ISP itself might issue a self-signed certificate. It's an end-entity certificate, and it describes some resources. It's actually signed with a new public key and signed with its old private key. Why would you do this? Well, maybe what you'd like to do is to say something quite definitive, that me, ISP4, permits some AS 65,000 to originate a route for my prefix 192.2.200/24. In other words, here's an authority being made publicly that if you see AS65,000 originating that prefix, the prefix owner actually said that's a good thing to happen. So how do you make that a bit more robust? You might attach onto that route origination a copy of the certificate, the end entity certificate you used, and you would sign it with its private key. Well and good. How would you use that? If you send it to me, if I see it in the routing system, if I see that somewhere, can I validate that? So the first thing I try and do is figure out, did the matching private key of that end entity certificate sign this text? Not any other text, this text, unaltered. And I can check that. Is that certificate actually valid? Do the dates match? Is it cryptographically correct? Do all the fields actually conform to a resource certificate? Is the certificate good? So far so good, but then there's the next thing. Is it truly valid? Can I find a trust anchor of my choosing, because I'm the relying party here? Can I find a trust anchor of my choosing and a sequence of issuer subject certificates that go all the way down to that end entity certificate? Is there a valid certificate path from a trust anchor I choose down to that certificate? Do all the dates match? Is all the cryptography working? If so, then I can say something very, very strong. I can say that it really was ISP4 that authorised that authority. I can say that it's a valid address that was duly allocated. This is not a hijack. I can even say that ISP4 owns a right of use for that prefix. And I can say that whenever I see a route object of that AS originating that prefix, then it contains, or it's done with, the explicit authority of that ISP, who's the current holder. That's a very, very strong statement, and certainly one that you are not used to in the routing environment we have today. So, what can you do with these kinds of resource certificates? If you are allocating addresses further down the food chain, you can issue subordinate certificates, so that when you allocate, you would issue a certificate to match that allocation. And every certificate you issue, you would store in your local repository, so you'd maintain a certificate collection that matches what you've allocated. You can sign things, and that's very important, because what you're really saying is, I'm doing this with the authority of that prefix or that AS number, so that now I can actually attach some authority to some of these objects that are floating around by effectively showing my certificate, my validity path, and signing it with a private key that says it really was me. And of course you can validate things. Other people can look at this and say, is this real? Did it happen? Does that resource holder really have that thing? Did they really do it, or are they lying their head off? Is this a hijack, or is it real? Is it valid today? Do I have the permission here and now? Those are much stronger statements that you're able to make if you can validate something than you'd otherwise be able to do. What would it look like? It would actually look a little bit like DNSSEC, I suspect, although it doesn't have quite some of the features or failings of DNSSEC, which I'd regard as a good thing. Here is a subtly altered object that you might see as a result of a whois query. It's got the usual stuff, the route set, the description, and so on and so forth, but there are two fields added. One is a URL pointing to the certificate that was used to sign this, and the second is a PKCS7 signature block, which is a signature over not only the external part but also the URL that says this certificate, this object has been signed. And if you looked up the matching certificate, note those members there, the IP addresses 58.160 and 203. The matching certificate, which you can validate, contains those same sets of resources, so that now you can actually say that the resource right of use owner, the resource holder, signed that object. Whether you believe it or not is now an interesting issue, because now you actually know it was done with the authority of the end user, the holder of those resources. Not everyone wants to run full-blown certificate authorities. Not everyone wants to fight their way through some of the intricacies of managing certificates in X.509. Indeed, if you look on the literature and do a basic Google search, PKIs are dead is a very common thing. Using PKIs is not natural, and certainly Strong security is not often cheap. How can we make this easier? How can we actually get the good, fast and cheap out of this model? Certainly as part of this trial we're looking at, can we do this via portal-based mechanisms and actually allow you to outsource a huge amount of the certification work that you would otherwise need to do? How can we create portals that simply generate and sign objects? How can we actually use such portals, if you're willing to trust them, to actually validate these signed objects? How can we manage all that subordinate certificate issue? And if you don't want to trust someone else, and maybe that's a very good thing, and maybe it's your business in not trusting other people, fair enough. What local tools can we put out that would allow you to do that yourself? To manage your own repositories, to manage your own validation caches, to be able to sign things and to be able to lodge certificates. All of that work is encompassed in the trial we're actually putting forward right now. Where are we? We've done a fair way. Certainly the specification of the profile of these certificates, we're pretty confident has been done now. And we're now actually generating test certificate repositories which are aligned with real-world data, aligned with the actual allocations that the RIRs have performed, and even the allocations that some of the intermediaries in the APNIC world national internet registries have performed. We certainly have built a number of tools for registration authority, certificate authority interaction, and that work has actually been done by the folk at the RIPE NCC in Europe, and also generated some tools that perform validation of these. Certainly more to go, and we are completing the work around extensions to OpenSSL. That's open source developmental work supported by Aaron, and Randy Bush will talk about that. Also those tools for certificate management, certification management and operation service profile are also underway. Next steps. We'd certainly like to complete most of this trial by the end of this year. At that point, as APNIC, as a regional internet registry in the Asia Pacific, we will be doing an evaluation of what we've managed to do and its impact, trying to understand what are the implications in moving from a trial into true production, actually allowing folk in that area to be able to have, use certificates, to be able to sign things and to be able to validate those results. And certainly there are some questions there about, is this approach really going to meet its objectives? You know, what are the implications in a broad policy sense of this? And how does it mean to us as a registry and you as ISPs and service providers in terms of your operating procedures, your operating support systems and similar? What are the policy considerations? And I think at this point, once I acknowledge the folk who have been working on this, from APNIC, George, Rob and myself, Randy and Rob from your region of the world, with support from Aaron, I believe, and Steve Kent and Russ Housley from the certificate world, and Rob Kistalecki from the RIPE NCC, I'd like to hand over to Randy Bush, who will tell us a little bit about the implementation side of this.
Could you back up 3 foils? As usual, when letting Geoff talk first, he covers just about everything I want to say. Pretty quick, that currently, if you'll have noticed, the real work is being done by a conspiracy of Robs, one from each region. And so we're robbing Peter, and the only Paul we've got is from APNIC. So all the money's going there. So the 3779 specifies extensions to X.509 certs to describe IP address ranges and AS numbers. In other words, it lets certs say this set of resources are a signed object. Okay, that's an extension to OpenSSL. That work is essentially done by Rob Austein, who's sitting over here. We only have one of the Robs representing all three, but actually he's been doing all of the heavy lifting. And that's currently turned back into the OpenSSL folk to be merged. It's open source. Those of you who work with OpenSSL and use it at all notice they've been in a release every fortnight mode for about 2 months now as vulnerabilities appear. So it's not yet visible publicly. Maybe the end of November, we don't know. It's up to their development cycle. Management. What this really is and we're going through 4 layers here. I would think of them going up, but here they're going to go down, and we're used to inverted trees. The second layer is, look, UUNet, or whatever you're called this month, Chris, and Sprint, and so on and so forth, are big. They're going to have their own repositories. They're going to have their own piece of the PKI structure, that the certificates they've issued. And it's going to be scattered just like the IRR data are today. But notice the IRR data, we really have only about 30 different IRR repositories. There has to be a tool set to pull this stuff local to you so that you have a validated set. And as it pulls it, it shouldn't be following pointers that could be, leading into outer space that would trap you, denial of service, et cetera, et cetera. So it is a validated fetch. And since it's based on something like rsync, and it's very suspicious, we're calling it for the moment rsync, because we're cynical about what it gets. And that is in current test and is also done. And it's being in final debug and testing. And if it were useful and somebody wants to play with it, it'll be out there, but you can't do a lot useful with it because you haven't got the structure to, with certs. This just gathers all the certs. What's happened is George Michaelson from APNIC has essentially generated the certificate structure that might be representative of a half or something of the total number of certificates that would represent all resources today. And on a machine that I've got, for instance, that's loaded with about 5 other large net applications, it takes less than a minute to slurp that from all the distributed thingy. So PKI is not expensive. Okay. The next layer is what we're in the middle of, designing, which is the tools for certificate management. In other words, when I, as an end site, go to my ISP and say, give me a certificate for my space, when that ISP goes up a level, etc. So it's kind of a parent-child relationship, and what are the transactions? And those transactions are currently envisaged to be a small message passing system with only about a half a dozen primitives and with very simple XML wrappers. Okay? Then the last is operational service profile, the web interfaces that different people will have, etc. But note that if we have these 3 formally specified and and provided across all the entities, that everybody is interoperable. For once, you will be able to do something in the RIPE region and in the ARIN region, and it will interoperate. Luckily, you're all sitting down because this is an exceeding shocking thing if you've been around very long. Okay, and RIPE, and as Geoff has pointed out, RIPE, APNIC, and ARIN have been co-conspiring at a very low level, just actually working engineers instead of large meetings and task forces to achieve this. And it is done with consent of consenting adults from each one too. But in the meantime, we're having a grand time. And the other 2 registries are very cognizant of this also, AFRINIC and BlackNIC. And so essentially, as Geoff says, you're looking at, next year, you're going to be able to play with this usefully. And this removes one of the 2 big obstacles for your routers being able to formally, cryptographically validate routing. But the routing vendors are going to do this probably after I've retired. Unless we're all in the Wall Street Journal some Wednesday afternoon next year, which probably will happen, unfortunately, before I retire. But it will be useful to you in the meantime. The first thing is, as Geoff pointed out well, when a customer comes to you in his first foil and says, hey, fix it up quickly, could you please route 192.192.192/24 for me? you can say, show me that you actually have the right to ask me that question in a formal, cryptographically verifiable sense. Okay? And in the same sense of looking up something in Whois today, you will be able to look it up formally. Okay? The next step is those of us who tend to build routing filter lists for our routers from the IRR data will be able to validate those data as we're fetching them against certificates in two ways. Number one is you can just say who's saying they have this and look up the certificate, but the other is, as Geoff pointed out in one of his foils, those IRR data can be signed with these certificates. In other words, when you say in the IRR, here is prefix 1472800, you can sign that with the certificate that represents the resource 1472800. Okay? So that stuff you can incrementally add to your operational structure that'll give you significant benefit today. End. Questions?
How long are you issuing certificates? I'm Russell John from Carnegie Mellon University. How long do you intend to issue certificates for, and are you using certificate revocation lists and have plans for distributing those also?
Every issuer by ob definito will have a certificate revocation list associated with the certificates which it issues. You're talking about a matter of policy. I wouldn't issue a certificate no matter how much you paid me. You can come to the ARIN meeting for the rest of this week and discuss how that policy might be in the ARIN region. The guess is, and this is in no way binding on the registries, is that they will issue a certificate whose lifetime is that of your contract with them. Your contracts with at least the two registries of which I play seriously, by the way, Geoff accused me of being from this region. I'm really work for a Japanese company, is 1 year. This means that the length of the CRL is actually not likely to be very bad, which I think was the underlying question towards which you were heading.
Yes, I was wondering if you were planning to use some automated tools for getting the CRL distributed when I do the verification.
During the verification, the CRL's checked, period. No question, it has to be.
If I could add there, the tool that we're using is all based around a certificate structure where the certificates you issue and the certificate revocation list that you manage are distributed within the same mechanism. If you wish to use a local case, you'll just suck up the lot.
Okay.
Thank you.
Daniel was actually escaping and wasn't asking a question. Next.
I think that's it.
Everybody wants to rock and roll. I'm stuck here for the rest of the week, so.
All right, thank you very much.